Good morning, guys. Welcome to another episode of 𝐠𝐫𝐞𝐚𝐭 Talk Show. Today is 2019. 2019, yes, it is. Stop that. And today is December 15th, Sunday, 2 o'clock in the afternoon, San Francisco time. So today, we have a lot of people. Hello, guys. Emily, Alan, and AOEU. Now, that is a Vorak left-hand home row keys. Uh, and we're gonna talk about, I'm thinking I'm gonna talk about JavaScript. I'm going to code JavaScript vectors, mathematics. Okay, you can see on the left window, this is math. This is all vector functions. We're gonna code that for 20 minutes, or we're gonna talk about languages. Look at these fantastic languages. Look at these characters. Now it's magnified, giant font. Okay, so so we have English, Latin alphabet. We have German omelette, and also used in other languages. And so I'm thinking, let's just talk about languages, because that's a fun topic. The languages of the world. And Alan says how, which means Chinese is good. Alan is multilingual. Alan is Alan is English, Chinese, Korean, and Japanese, and others. And Emily is also English and Japanese, and Lojbang. So we have fantastic people. So you see, we have English and omelette, and niña, the Spanish niña. That's a word. That's a character I remember. Niño and niña. Niño is for boy, and niña is girls. Sweet. And we have this Russian character. So let's talk about random. Let's do random then, I guess. Unless you guys are here for my JavaScript thing, for my mathematics and geometry. Okay, so Emily shows a purple heart. Emily is fond of the purple heart. Okay, so so we have Russian. Okay, let's go to Unicode. Okay, Unicode, fantastic Unicode. So let's go to Chrome, open browser in Chrome, and of course we are using Emacs, the best editor in the universe. And on this window, you can see all my command names. Okay, so let's see. So we opened Chrome, and let's okay. So but we have to have like a goal, or like we have to do something. Otherwise I'm gonna be dependent on you guys chat. So we're gonna do something. So first of all, pop this out as usual and move this window to the right. Okay, so we need to do something. So what is that something? I don't know actually. I don't know what is that something. So I'm thinking. So let's look at first of all, let's look at the Unicode. Okay, so this is my website. If you like my stuff, and you want to support me, then spread my website. Okay, so let's close that. So let's go to 𝐠𝐫𝐞𝐚𝐭 Talk Show. Emacs bookmarks, fantastic. And today's talk show, and let's paste it there. So Unicode. Oh yeah, I already pasted that. So delete that. Go back. Great, and refresh. And also join my Discord. Okay, so you see we have so open. So go to 𝐠𝐫𝐞𝐚 Talk Show. Go to the top, search for Discord, and there is the link. This is my 𝐠𝐫𝐞𝐚 Talk Show page. And yeah, so go to Discord. Where? So over here. So those of you new here, and today we have so much good discussions on so many things. ancient astronomy and astrology. Good morning, George, to Australia. And we have people all around the world. We have Lunarus, which is from Halifax, Nova Scotia, which is on the east side of Canada. And we have Ripper is from Colorado, and Crash Hacker is from India and currently in Japan, and Alan is from the Great California. the you guys know the California flag, which is the bear. Okay, actually, some of you do not know, so let's show it. California flag. In USA, each state has a flag, and California has, so this is the California's flag. Okay, which side should it be? I don't know which side. So anyway, that's the California bear. Why is California using a bear as the? Well, I guess in the past there's lots of bears, but we don't have much bears today. Not in California. I'm wondering why is California using bear as its flag? Because California is not cold. Oh, grab a drink. Oh yeah, we must. We must do. So my drink of today is the grape juice, 100% grape juice. You want the fantastic. You know how much work it does to make this like juice? Tremendous toil and moil. Oh, Emily has to work tomorrow, so that's toil and moil, guys. Toil and moil. That word I learned from um, Arabian Nights from this guy. So anyway, we have wait, that's the quarantine song. So we have languages. We have the very interesting and fantastic keyboard. Oh, I must mention, I must show a little keyboard here. And we have all the people who know this keyboard, Japanese keyboard, who are enthusiastic with this keyboard. And Zumwelt, there you are, Zumwelt. And Zumwelt showed us today this keyboard, okay? And there's also a video, he's typing it, showing us how it sounds. Mechanical keys, of course. And you can see the key right here, okay? It's one of the rare key. Alf's mechanical Alf's blues oval, something like that. And that's actually new to me because I don't know much about Alf key. You guys know. Okay, so other people here knows a lot about keyboards. But one thing interesting is that you see, apparently, the Japanese company NEC created this keyboard. So it just looks like a IBM PC keyboard, but actually it is was it NEC or Fujitsu? So because you can see on the back they have so let's argue at this keyboard. So it just looks like a American PC keyboard, IBM PC keyboard, but it is made in Japan. Look at that. You see, so this is NEC Corporation, NEC APC H4112. So I have no idea, but that's very interesting. So anyway, let's get back to NEC. So let's talk about Unicode. So we have this Canadian Aboriginal syllabics. Okay, so Canadian Aboriginal syllabics. So actually, what I'm thinking I'm going to do is that I'm going to create a page on the fly. I don't know if that's interesting to you guys, but you guys chat random, so I'll read it and so let's so. But before we do that, let me show you some of the interesting things. So you go to my website. So actually, let's go to 𝐠𝐫𝐞𝐚 Unicode. search for it, and there it is. And we have several JavaScript ongoing. So let's look at that one. This is math font. Okay, let's shrink a little bit. So you type here, and see them change in real time in this Gothic styled font. This is actually not a font per se. Now, per se is Latin. But this is not actually a font, but it is actually a Unicode characters. So these are Unicode characters, and you can change them to double stroke and mathematical bold. So you see, the interesting thing about this is that it's actually not bold, but it's actually but it's actually Unicode characters. So these characters are bold by themselves. You are not actually bolding it. So what's the use of these? Many people on Twitter, they would use these. For example, I have a great day today. For example, I type that. Okay, I copy this line, go to Emacs editor, and I let's say I paste it here. Okay, shrink a little bit, and I say I have a, let's magnify. Okay, that's actually great day. So you see, you post this on Twitter. Now actually, let's change it to text mod so that there's no highlight. So you post this on Twitter, and that word great will be bold. So that's what, it's a fun thing to do. Then you have math italics, and you have math script, and you have math mono. So all these are Unicode characters. That's very interesting. Then you have several others. You have the rune characters. Rune is a script used in Scandinavia, basically, starting around year 150 to about 1500. So this is the rune script, and of course, Tolkien, Tokien, this guy, Tolkien, who wrote Lord of the Rings, also has a hand in it. He's got a hand in everything linguistics, but not Asian ones though. I mean, but the European. So because he actually added several characters to it, and they appears in Unicode. But however, the fonts is not widely available. So you see these three characters, those are from Tolkien, from his Lord of the Rings novels. But okay, speaking of rune, there's something interesting. Okay, when I was reading about it, so you have a keyboard with rune keycaps, and also, by the way, so another interesting thing about rune is that, let's go to 𝐠𝐫𝐞𝐚𝐭. Now, Golan people, the Rob Pike and friends, they in Golan, they have a data type, the type of the language. Let's see, Golan data type. So let's see, let's show that there. So back to the Golan data type, basic types. So you have a type that is uint32, which means an unsigned integer, 32 bits. So basically a binary number with 32 digits. It's an integer, and they use that type to represent Unicode characters, and it has an alias. So this type uint32 is also called rune. Why is it called rune? just because the Golan guys, they are nerds. They wanted to do it. So I suppose that's the reason. No other reason. The proper name for this type uint32 should be Unicode code point, because that's what this type is used for. So you can, so Unicode code point. But anyway, they call it run. So Golan, they have a data type called run. Now let's go there. Okay, so I have a page, a tutorial about run. Where is it? Run there. So run. So on this page, I show you what this data type is about. The type, one of the data type of the language and how you use it. Purpose of run. What's code point? Run is just code point. Okay, Unicode code point. And if you don't know what Unicode code point is, I did a video a few months ago, and we gonna this Rockstar $1 per bottle at $1 tree. So grapefruit juice and Rockstar, and I'm gonna be a rock star. So if you are new to, if you haven't learned Golan, I recommend it. Okay, just go to 𝐠𝐫𝐞𝐚𝐭 Golan tutorial. I recommend Golan. It's fantastic. And the primary reason, the actually the important reason is because it is practical and it is widely popular. It's gonna wipe out C and C++ and Ruby and Python soon. Okay, I'm gonna tell you so. As opposed to the scheme Lisp, the Haskell, okay, the Clojure. Yeah, they are good, but they are not gonna be. You are not likely gonna get a job. But meanwhile, Golan, as of right now, there are tons of jobs, and it's very practical. So I recommend Golan. So Golan, they introduced, they use the term run to represent Unicode characters. And okay, let's go back to Unicode. So that's about run. That's interesting thing about run. So let's see what are you guys saying? Leave a cirrhosis. Here I come. So everyone grab a drink. You have to take a shot if Xa has to turn off JavaScript. No, I don't have to turn on and off. So you guys actually I should. You guys are spared of taking a shot today because I'm in Chrome, baby. Melodious voice. Okay, let's do that. So guys, thank you very much for attending my show, and you guys are great. And and and, and what? So we are going to talk about run. In fact, we just finished talking about that. So let's go to the next topic. And this is going to change your life. I'm going to help you change your life. Okay, so look at this. Look at this one. This one will turn your life entirely upside down if you follow what I mean. Okay, so so that's upside down letters, and it's fun to put it onto. For example, let's demo an application. Let's do an application. Let's help the world. Let's make the world a better place. So let's go here, a vibrant discussion group, and paste it there. Paste. Oh my God! What? Okay, so what are those? Black letter, black letter. So okay, so let's go back to Chrome and let's go back to Unicode. So inverted text, and lastly we have Braille, which is great for those blind and deaf. Excuse me, for those who are um, well, who are capable in other ways. Okay, so this is Braille, and it is basically the X EXHIBITION exhibition of mathematical combinatorics. You see, they even have exclamation sign. So Braille, so that's fantastic. And so how long have I been talking? And we've been talking for 20 minutes. So next thing, what are we gonna do next thing? So shall we do the Aboriginal? What do you guys think? So let's Braille. Okay, so Braille is interesting, and let me show you. Let me say something interesting about Braille. So Braille is basically a combinatorial exploration of dots. And by the way, Emily has her own writing system she created. Let's do that. So 𝐠𝐫𝐞𝐚𝐭, let's see Emily. Okay, let's. I don't know what that will come up. Let's go to 𝐠𝐫𝐞𝐚 keyboard. Okay, 𝐠𝐫𝐞𝐚 keyboard, and okay. So let's show this quickly. So we have on 𝐠𝐫𝐞𝐚 keyboard. Oh yeah. So this once we started to talk about keyboard, it's gonna be non-stop. We're gonna be lingering over here and never be able to get out. But you go to the fun part, and there are these battle stations you can argue at. So then you go to Happy Hacking Emily Lisp server. Then you can see this writing system she created. Okay, so she created this writing system, and it's also if you want to classify it, it will be a combinatorial system because it's based on nine dots, similar to Braille, nine dots. Then you connect the dots by a line. So depending on how you connect them, you have different configurations, and then you have this thing. And she wrote this thing, her diary. Okay, so that's that's the interesting thing about the combinatorial systems. Okay, so let's post that here and then go back to Braille. And okay, so Braille is actually made of two columns. Okay, two columns, three rows. So a total of six dots. But actually that's not all, because there is a new Braille. Okay, there is a new Braille that's made of 8 dots. So you can see here. This is this is not popular. Okay, but it's some sort of extension. So they extended Braille with 8 dots, but it's not common. But you can see, when I was doing this Braille page, you have an interesting mathematical question that will interest you programmers. Okay, so the question is, how do you order them? So you have a bunch of dots. Let's say six dots total, like that. 6 dots. Okay, then some dots can be on or off. Now the question is, you have this different combination of dots. Now you want to order them like A, B, C, D. So what are the ways you order them? Of course, there's no standard way. I mean, you have to come up with in mathematicians jargon, this is called Let's see if I can pull it off. In math jargon, this would be called total order. So you have okay. That's not a obscure jargon. It would be better if I can come up with some jargon that you don't understand. But anyway, this is called total order. Okay, so actually, uh, let's digress into the realm of mathematics. Total order. Oh, shut up. Wikipedia, please go away. I don't have money. Okay, don't donate to Wikipedia. Okay, I made a video about that. So in mathematics, a total order, simple order, linear order, connex order. Oh God, what are these? This they should be removed. So a total order is a binary relation on some set X, which is antisymmetric, transitive, and connex relation. What is connex relation? They just added that. God, some PhD student just added that fluff because I never seen that before. Connection relation. What the? In mathematics, a homogeneous relation is called connex relation, or a relation having the property of connexity. If it relates all pairs of elements in some way. Shut up. Okay, so let's go back to the math. Okay, order, total order. So in math, a total order is a binary relation on some set X, which is antisymmetric, transitive, and connex relation. A set paired with a total order is called a chain. Oh, it's called a chain. Okay, guys, we have a now. So you see, also our problem to express this in a mathematical way is that we want this set of brailles to be a chain. Okay, so it's a chain. So you see, then they started to talk about what are these properties mean. This is actually important. Okay, this is how you, you know. So anyway, braille. So you want to order them. By that, basically, it means for any two braille character, you need to come up with a function that says which one comes before the other. Okay, that's what it means. However, this math is actually important. Because you see the mathematicians talk about these things. You might think, that's too much jargons, unnecessarily. So actually, it's so necessary. Let me tell you why. Because when back in 1997, I was doing a lot math. Learning. Actually, I know much more than at that time. I don't know that much math, but I was. So anyway, I was doing programming, coding, and I want to sort. In fact, this problem is a major problem in a practical problem you might run across. Okay, let me tell you the story. So you got a bunch of, let's just say braille. Okay, so you got these characters, and you want to sort them. Now, each of these braille characters, they have a Unicode code point. You see, for example, these 6 dots is that number. It's kind of like an ID integer. It's a code point for this character. And in hexadecimal, it's that. Then, well, wait, what? Okay, so wait, the code point is this one. It's a bit confusing. So these 6 dots, the code point is 10303. What comes above that is actually the braille pattern dots. They actually have an ID by themselves. So you see what I mean? So let me show you another character. So let's go to APL, programming language, APL characters. So here we have the APL characters. Now let's show one of them. So let's see the right arrow. So you see the right arrow, the name is rightwards arrow, and this number 8594 is its code point. Basically, It means it's an integer that identifies this character. And in hexadecimal, it's 2012. Now, with U and plus sign before it, that's the standard Unicode notation. So anyway, you got the ID, code point of this character. But for the Braille character, the full name, for example, these 6 dots is Braille pattern dots 1, 2, 3, 4, 5, 6. So they have actually, the Braille characters themselves have a ID, a code to indicate this character. Then you have this 10303. That is the Unicode code point ID for this Braille character. Okay, then you have hexadecimal. So anyway, if you want to sort Braille, of course, you could just sort it by the Braille name, the Unicode name assigned to it. Or you can sort it by the Unicode ID, code point. Okay, that's code point. You can sort by that. But actually, it turns out if you sort by that, the result is not very logical. For example, in this column, and let me get rid of that. So in this section, they are sorted by Unicode code point, and you look at them, they don't make much logical sense. You see 1 dot, 1 dot, then 2 dots, then 1 dot again. It's not logical. Then, okay, let me show you some. You see, you can see there are several different ways to sort them. You can sort by the Unicode code point. It doesn't look good. Then you sort by the Unicode name of the Braille. Then it looks like that. Okay, like here. Again, you can see. You look at that. It's not logical. You see, you got 1 dot, 2 dot, 3 dot, 4 and 5, 6. Then you start with a 5 dot, 4 dot, then what, 5 dots again. It's not logical. This is sorted by the name of the Braille. But however, the logical one of the logical way to sort it is by dot count. Look at this one. Okay, so look at this one. So you see 1, 2, 3 dots, then 1, 2, 3 dots in a different column. Then you have variations of 2 dots. Then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15 variations of 2 dots. Then you have variations of 3 dots. So this is a logical way to sort it. But okay, so that's about how you about sorting them. But when you want to write a program to sort something, let's say polygon, let's say some object. Let's say the object represents some polygon, some polyhedra in space. Okay, you want to determine the order if, for example, some polyhedra's volume is smaller, then it should be in front. If the polyhedron's volume is larger, it should be in the back. So it's like, this is like computer graphics, computational geometry. So basically, you have a bunch of variables that each one is a data type of a polyhedron in space somewhere, and they have different sizes. You want to write a program to sort these polyhedrons. How do you do it? So typically in programming languages, you have a sort function that takes a second argument. The second argument is a function that determines which one comes in front, right? So you basically pass your own function. So then you compute the volume of the polyhedron. The smaller one will come in front. So you write that function. But if you are not careful, you've got a problem. The problem is every time you sort, the result is not the same. It's almost like there's some kind of a random thing going on, even though your program has nothing random at all. That's a problem. You see, that happens when you violated these mathematical properties in your function. Okay, this actually happened to me back in 1997. I was sorting polygons in 3D space, doing visualization of math. I'm programming that in Mathematica. So I want to sort. I forgot what's the criteria, but I want to sort the polygons in 3D space. So I write a function. I can write a function easily to say which object should come before. A less than B or B less than A. But every time the sort result is not the same. You sort it now and you sort it again, it's the same. But next time you sort it, it's not the same result. The problem that happens when your sorting function does not conform to these three properties. Okay, so for example, if you sort A less than B, it must always be so. It should never happen when B comes before A when your function returns that. And also, the most important is this one. This one I violated unknowingly. So this one says if A is less than B and if B is less than C, then when you apply your function to A and C, it should say A is less than C. So this is called transitivity. So if you violate this function, I mean, you don't know. You have to analyze your function for the order, because otherwise there's no this like you see, this is when unit tests will fail. Like unit tests, they will fail. Because your program, your function doesn't. There's no way to say when given two object which one comes in front unless you run your function. But your function must satisfy this property for any A and B. If your function says A is less than B and B is less than C, then it's required that your function also must say A is less than C. Otherwise, you got problems. So that's when you sort, the result is not always the same. So that's about that. So this braille. So writing this page, I try to sort them by the Unicode code point. It doesn't look logical. Then I try to sort by the Unicode name. It doesn't look good. Then I have to sort by the dot count. How did I do that? I don't remember. Okay, I don't remember how did this. Uh, Maybe manually. No, I don't think it's manually, but I don't remember how I actually sorted them. So anyway, that's the interesting thing about sorting. About two things, three things. Okay, the sorting of the brailles. How do you sort them? That's very interesting. You can go by Unicode code point. You can go by Unicode name, which is a braille's own ID, or you can go by some kind of logical dot count. That's one thing. So the other thing is about the mathematical property of sorting. Your function needs to satisfy these. So that's interesting. Well, that's about that. So then we have APL symbols. Okay, yeah. So APL is a mathematical programming language. So how long have we been talking? 40 minutes. Okay, so maybe that's it, I think. Or let's look at the comment and see what's interesting. Okay. So yeah, that's all I have about brailles. But I was thinking, let's add the Canadian Aboriginal text. Okay, so there's a Canadian Aboriginal language writing system. But let's read the comments first. Where is it? Okay, today it's so busy. My God, the Discord channel. I cannot read all the messages anymore. Where is it? Yeah, so this Canadian Aboriginal syllabics. So apparently there's a language in Inuit. Okay, so Canadian syllabic writing is a family of Aboriginal, okay, which means writing system based on consonant vowel pairs. Let's just call it phonetics. So it's a family of phonetics created by James Evans to write a number of indigenous Canadian languages of the Algonquian and Inuit and formerly Athabascan language families, which had no formal writing systems previously. Oh, that's interesting. So it's it's actually artificial shit. That's well, that's still interesting, but it's not. It's basically man-made, human-created writing system to cover the Canadian Aboriginal languages. Okay, so that that is kind of that's still interesting, but in a different way. Because I thought this is some Canadian languages writing system, but so apparently the Inuit language, the language who has 1,000 words for snow, Eskimo. They have 1,000 words for snow, guys. So apparently they don't have a writing system. Okay. Okay, so I was thinking I'm gonna use Emacs to create a Unicode page on this. Maybe not. So maybe that's it for today. So let's see what else. Gigabugs like Wikipedia. What? Oh, okay. So more comments. More comments. What do I know about astronomy? I don't know much about astronomy. Well, I know about astronomical science. Astronomical science. The okay. So astronomical science. It used to be in astronomy. We use these signs. For example, these planets: Mercury, uh, Venus, Earth, male. Well, male, and that's Mars. They are named after the Greek gods, actually Roman gods, but the Roman gods borrowed the Greek gods. Jupiter, Saturn, Uranus, then astronomical symbol for Uranus, and Neptune. Then you have the astrologies. Yeah, the astrology science. Okay, there is, which is every day in newspapers and women's magazines. Astrology, and you have to put them there because people need it. And then astronomy is intimately tied to weather, which is intimately tied to food. You know why trigonometry and all the math developed? Because of food. You want to eat, you need wheat and rice. You want to have wheat and rice, you need to know the weather, the patterns, the patterns of the gods. And if you want to know that, you gotta know trigonometry and stuff. You gotta know basic astronomy. You look at the heavens, see what's going on, or then you know when it's summer, when it's winter, and stuff. The the commencement of civilization. Math, trigonometry, and anyway, so there are some interesting things here. Okay, then okay, so Pluto. Then well, I don't have font here. Some obscure symbols, But anyway, in the early days, astronomy, they used to use these symbols. Not today, well, because we become more advanced. And you have this sextile, semi-sextile, sesquiquadrate. Then you have quincunx. Okay, then you have well, actually this one is this dice. Okay, this Unicode calls it dice face 5. No, this is actually called quincunx. Okay, this character. In fact, you can look up Wikipedia. Okay, search that for that character. You'll see quincunx, not the dice, man. Let's see. Okay, so let's just type quincunx. 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 Fascinating. The fascinating history of human animals. Look at that. So this is called quincunx. Okay. And why? Because, well, there's a history to it. Somewhat complicated, I guess. Quincunx. So, so when you look at the Unicode, you learn about these things. You learn about these obscure random things. And there we have the symbol for descending, ascending node, conjunction, opposition. And some of these are used in astrology. Okay, so for example, this this sextile and sextile scenary, Emily, scenary, scenary, and hexato and hexamal and sexamal. Okay, so I guess I'm getting boring. So let's shut down in 3 minutes. So you have this astronomy symbol. So yeah, I don't know much about astronomy. It's interesting, so much to study. Astronomy, physics, cosmology, chemistry, biology, and in fact, I was watching a video that tells you how to live up to 150 years, but be young, stay young like you are 30 years, 30 forever. And in fact, that is possible, and we are approaching that. Yeah, we are approaching that, and that the science of that is called senescence, Senecine, something like that. I spelled it wrong because English spelling senescence. Okay, senescence is the scientific word for the study of aging. Now, what does aging means? I mean, from a biological point of view, you study your cells. For example, we know what aging is. You get old. You get ugly like me. You lost your hair. That's aging. But what does it mean actually in terms of your cells, your biology? Well, so they study that senescence. So that's a word. Okay, that means biological aging. You look at aging from a biology, the cells, what happens to them, what they do, how, what's the difference between a young person and an old person in their body cells. You study them. So that's called senescence, biological aging. So today we actually know some of the reasons why we age. And so if you can actually you can practice, you can how to live up to 150 but stay like 30 years old. You suffer hunger and you suffer the elements. That is, you want to do intermittent fasting. Okay, you want never eat a full meal. You drink, you go to Starbucks and drink, oh, good drink, and you eat fish, you eat cuisines, you eat gourmet, you eat all the fantastic, wonderful things that technology has brought us around the world, like in California, well, especially in California, well, in many of big cities. You go to the street, it's Chinese food, Japanese food, oh, sushi, oh, Indian curry, oh, fantastic. Then you have lamps, then you have the Greek sandwich, you have the Islamic how do you call that? That's kind of a blob of. Okay, so you guys, what's the food that that basically came from Middle East, Arabic country eat? I can't remember the words at the moment. It's on my tongue, but it's like a blob of mashed. That's made of. It's kind of mixed with olive oil. So, guys, what's the word? What's the word? No, not gyro. Gyro is like kind of a Greek sandwich, I think. It's okay. The texture is like mashed potatoes. Okay, it's eaten in Middle East shawarma. No, it's pretty common. Okay, so actually, I go to the fridge. No, no, not those. Hummus. Yes, thank you. Hummus. Now, have you guys seen that? We have a restaurant down here that's just focused on hummus. I didn't know what the hell that is until like 10 years ago. I went to this girl, okay, girlfriend in Maryland, and she introduced, she showed me this thing, and this thing is fantastic and it's fulfilling. This hummus thing, okay, so it's so the texture is like mashed potato. It's all soft, creamy, but it's made of oil and I don't know. You go look at Wikipedia, and it's fantastic. In fact, I have a actually let me go get it. Okay, so anyway, the trick to live longer and stay young is you do intermittent fasting. Okay, and I'm going to get that hummus, and that will be it today. Let's we shut down in 1 minute. Ooh, there it is. Chickpeas. Yes, it's made out of chickpeas, and they put olive oil on it. And so there is the hummus. So you can see this is like $6. Okay. So it's like it says organic. Well, in California, everything is organic. There's nothing that's not organic. Okay. So that you cannot see well, I guess. So let's put this. Mm, mm, delicious. So we close down in 1 minute. Thank you guys for coming. And let's see what you guys are saying. What are you saying? Check out the diet of Orthodox Christian monks. Show. You know what is Google doing? So when you say check out the diet of Orthodox Christian monks, Google is gonna censor it. In fact, it did. Jesus. Oh, Reaper. Hey, Reaper. Finally, I see you on YouTube with the same name, Reaper Grim. Correction. Thomson and Pike developed UTF-8. Yes, I know, and they developed it on a napkin. That's the Unix. The Unix people, the Unix philosophy people. They love to chant it every day. Chant, chant. UTF-8. It's developed on a napkin. Okay. Bye, guys. Have a good day. Sunday, and tomorrow you're gonna go to work. Well, you make money, right? So, anything else? Last words. Say your last words, and we say goodbye. You're gonna say your last words. Keyboard poem. So we have keyboard poem. We have California flags. We have Eskimo. Eskimo. Inuit. How do you pronounce it? Oh, Ad Alijut. Wait. How do you pronounce Inuit? Inuit language. Oh God, it's so complicated. Then they mention so many other things. The endless pit of the Wikipedia. Endless. Good morning, Bart. Yes, I want your salaries. Bye, bye, guys. Where is it? Oh, not edit.